Hi there, I'm Ashton Pula.
And I'm Arjun Babla, and this
This
is
is our
our product,
project, Aeolus.
Aeolus. Aeolus, named after the Greek god of wind, harnesses the power of something we have all played with as kids, but something that has the power to completely revolutionize the renewable energy industry kites.
Aeolus is an airborne wind turbine powered by the immense lifting power of kites, which can be demonstrated in activities like kite surfing. Kites can also reach incredible altitudes and fly for an incredible amount of time.
Airborne wind energy is advantageous to traditional wind energy for a few main reasons. The first is that it requires no setup and can be deployed out of the box. The second is that, well, it can be shipped in a box. The lifting power from the kite eliminates the need for a large beam and supporting infrastructure and enables turbines to go as high as 100 meters into the sky, which leads me into the third advantage. Because of the height these things can go to, these turbines can collect over 5 times the energy of a normal wind turbine because wind speed increases with altitude, as well as producing less noise, taking up less land, and being able to function in higher winds.
In addition to scaling up, they can also scale down, allowing wind energy to be accessible to anybody. And with a much higher energy output and a much cheaper price than solar. And when we say anybody, we mean anybody. These turbines are so cheap and easy to set up that a small sized one can be deployed for as little as $800 in developing countries, as well as on people's farms, on fields, or even houses and buildings.
Now, onto Aeolus's technical aspects.
First, we explore the lifting potential of kites. Using the lift equation and choosing a conservative zero point 0.6 as our lift coefficient, we get the following graphs for our small sized kite. At 6 meters per second, we get 10 newtons of force or 2.2 pound force. This corresponds to our experience of our kite lifting up to 1.8 pounds of pennies.
The next component is the turbine. The turbines work by having wind flow through them. At the higher altitudes we can achieve using these kites, we get much higher winds because of the boundary layer effect and the lower friction coefficients that the air faces. This gives us larger magnitude wind speeds, which means more energy being generated. Lastly, we have wires connecting the turbines in the air to the ground so that they can transmit the energy they generate where it can be stored.
We propose using a drone with the landing gear attached to the kite in order to safely take off, land, and sustain the kite automatically according to wind speed. The drone is lightweight because it doesn't need batteries and it is connected to the ground via tether.
Next, we have a small control system on the ground, consisting of a reel connected to the motor. Then, with sensors on the kite and on the ground, the motor can turn to always keep the slackline tensioned, mimicking a human flying a kite.
Now, onto the business side of things. We have a few methods of generating revenue. The first is selling turbines. By manufacturing these models the same way we did with the prototype, we make an average margin of 40% per kite. This includes the materials, electronics, labors, and shipping costs. We anticipate that we could get this production cost down by almost half by scaling up.
Our second method of revenue generation is leasing turbines. When a company leases our XL turbines, they pay a starting fee of $400 per month for a 24-month minimum. And we set up and maintain their turbines. Later down the road, we also plan to deploy our own kite turbine farms and sell our own energy.
Developing countries account for more than 90% of the global energy demand growth. Not just that, we're talking about clean energy. Our turbines would be the perfect addition to developing countries to directly power their community without expensive infrastructure, being cheaper than gas and other sources, and being more reliable than their current systems. On top of that, with connecting 4G and Wi Fi antennas to our kites, we're going to be connecting these countries to the internet and help unlock countless possibilities to the population.
In the sector of airborne wind energy, the only companies that come to mind use an inherently different and much more complex design involving either rotary transmission, which is filled with flaws and breaks often, or the use of a kite with a ground station, a very expensive to build and maintain option.
Airborne wind energy has an estimated market size of 131 million today, with growth projecting to reach over 200 million in 2028. This is the perfect time to enter the market because few people see the immense potential of these beautifully elegant pieces of engineering.